Dear students, we were talking about organisms and populations, the chapter 10 or 11. In that one, we started the concept of abiotic factors. And the abiotic factors already completed the effects of temperature on living organisms. And related to temperature, there is one rule proposed by 1/2. That's why it's called 1/2 rule. So a proposed rule in that for every 10 degrees Celsius increase in temperature, the rate of reaction is doubled. Or for every 10 degrees Celsius decrease in temperature, the rate of reaction is halved. That is reduced to 50%, from 100 to 50%. This is the rule. Okay, for every 10 degrees Celsius increase, the rate of reaction is doubled. For every 10 degrees Celsius decrease, the rate of reaction is halved. And that is the rule. Now, the effect of temperature on the rate of reaction is normally expressed as temperature coefficient. Expressed as temperature coefficient or Q10 value. How can you calculate the Q10? So, it is a ratio between the rate of reaction at x degrees Celsius and the rate of reaction at x minus 0 degrees Celsius. If you are calculating the value in a living system, the Q10 value is equal to 2.0. The meaning for that one, for 10 degrees Celsius increase and the rate of reaction doubles. That's the meaning. So in a living system, the Q10 value is always 2. So this is the rule related to what we have the temperature and the effect of temperature on the rate of reaction, namely the metabolic activity in a living system. And that is called temperature coefficient or Q10 value. Because for every 10 degrees Celsius increase, the rate of reaction doubles. That's why it's called as Q10 value. It's about always 2 in the case of a living system. That's all about the temperature. Now we have to go for the effects of light on living organisms. The next abiotic factor is light. So light is an important and essential abiotic factor. Now what are the effects of light on living organisms? Ecologically speaking, number one, the quality of light, referring to the wavelength or color. Number two, the intensity of light, that is actual energy in gram calories. And number three, distribution. That is nothing but the length of the day. All these factors of light normally is considered significant for organism, essential for an organism, these three factors: quality, intensity and distribution. Now what are the other effects of light? Light influences the growth of an organism, pigmentation. The organism which is exposed to light being pigmented more, and when it is found absent, then automatically, for example, the case of cave-dwelling animals, the pigmentation becomes less. Then migration. The bird's migration is now influenced for a long distance because of the effect of light. That is lunar rhythm. Then also we have the reproduction. The rate of reproduction increases in the case of what we have animals which are exposed to more light. Now, the intensity and frequency of light normally influences the metabolic activity, the chemical reactions, and also induce mutations. For example, the radiations like X-rays and UV rays cause mutations. Now, light is also essential for vision. So, you can just find out, there is an example in the case of cave-dwelling animals. As there is no necessity for them to have light, the cave-dwelling animals have either the eyes absent or the eyes are poorly developed. So light also influences or responsible for vision. In cave-dwelling animals, there is a darkness, there is no need to have eyes. That's why the eyes are absent or poorly developed. Then it is also responsible for what's called diapause. Diapause. It is also responsible for diapause. So light influences diapause. A state of suspended activity, a stage of suspended activity. This is called diapause, a stage of suspended activity. The animal stops its activity during extreme conditions. It is seen in the case of lower animals, for example, zooplanktons. It is seen in the case of zooplanktons. So diapause is a stage of suspended activity. The animal stops its activity, and example zooplankton. And the light is also normally responsible for increasing the activity of gonads. So the gonads of birds become more active with increasing of light in summer. So that is happening in the case of birds. Increase in light increases the activity of gonads. That happens in summer. Light is also essential for the movement and locomotion of organisms, particularly in the case of lower animals. So it's also responsible for locomotion and movement. We have cyclic movement in the case of certain animals during what is called the light intensity. When there is low or high, accordingly they are moving either in a cyclic way, in a horizontal way. We have different movement. So the movement and locomotion is normally controlled by light. So these are some of the effects of light. There are certain movements also related to light. We'll see now. I already explained the effects of light in diapause condition, effects of light in gonads of birds, and also we have the movement and locomotion. You go through that one. Now we have different types of movement in response to light. Number 1, phototaxis. Number 2, phototropism. Number 3, photokinesis. So in taxis means the movement of the entire organism towards a stimulus or away from the stimulus, movement of entire organism. Now phototaxis, the movement of an organism in response to light. Either the organism is moving towards the source of light, then the condition is called positive phototaxis. Example, moth is always attracted by the light, it is moving towards the light. The organisms are moving away from the source of light, then it's called negative phototaxis. We have the examples earthworm, then we have the volvox and euglena. What we have an organism exhibiting both plant and animal characters. So that's about what we have phototaxis. The next one, what is called phototropism. Here it is in response to the movement of an organism. There it is in response to what is called the growth or orientation. Growth or orientation. A particular part of the body, here taxism, the entire organism is moving, but in tropism, either phototropism or geotropism, etc., the entire organism is not moving, only a part of the organism is moving towards the source of light or away from the source of light. That is called phototropism. So in phototropism, it is nothing but the growth or orientation of what is called the organisms in response to light. It may be what is called positive phototropism, as in the case of, for example, sunflower. Its part, the stem is moving towards the light source. That's a part only. That's called phototropism, particularly positive phototropism, moving towards the light, as seen in the case of sunflower. Now if you're taking the next one, what is called phototropism, that is a positive phototropism. In negative phototropism, the part of the plant body is moving away from the light source. For example, roots are negatively phototropic. So that's about tropism and taxism, the differences. Taxism, the entire organism is moving. Tropism, only the growth or orientation of a part of the plant body towards the source of light or away from the source of light. One more, we have photokinesis. So I'll go through that one. Now the next type of movement in response to light, what I explained in the previous stage, that is phototropism, response to what is called actually the light. That is a growth or orientation. We have positive phototropism and negative phototropism. I explained already. Now the last type of movement in response to light, photokinesis. This is nothing but the change in the speed of locomotion, or we can say frequency of turning. Particularly in the case of motile organisms, for example paramecium, or in the case of euglena or chlamydomonas, or cells, individual cells, unicellular organisms, normally which is made in response to change in the intensity of light. when there is a change in the intensity of light, that is wavelength or color, etc., they exhibit the speed, that is moving away or moving towards the light with the speed. So change in the speed of organisms in response to light is normally called what is known as photokinesis. Now it is normally made, you know that one, all these changes in response to change in the intensity of light what I mentioned. So it involves undirected, random movement. It's not moving in a particular direction, undirected, random, in any direction, either moving away from the light in a different way, haphazard way. Undirected random movement. Okay, undirected random movement in response to light, and that is called photokinesis. And with that I conclude light, we have to go for what is called water. You know, water, the life or earth begins only from the seas. And water is essential for all forms of life. You know that one. About 3/4 of land surface is covered with water. Hydrosphere. The area with water is called hydrosphere. So water exists in 3 different states or forms, either in gaseous state or in solid state, for example ice, or in liquid state. Okay, now again we have 2 different types of water. One is the fresh water without salts, for example the rivers, lakes, etc. Another one what we have the marine water or salt water, the one which contains salt. And again based on the dissolved salts, we can classify the water into hard water and soft water. Hard water contains salts like nitrates and sulfates of calcium and magnesium. And the soft water contains only little amount of salt. If the boiling process removes the salt and converting the hard water into soft water, then it is called actually a temporary hard water. If boiling does not help, then what is called the hard water is called permanent hard water. So if boiling removes the salts and making the water soft, then it becomes a temporary hard water. On the other hand, if boiling does not help in converting the salt water into soft water, then it's called permanent, what's called actually, that is a water, hard water. That's about the introductory part. Now we have to see the effects of water. I mentioned about something water, about the types of water. Based on the dissolved salts, we have hard water, soft water, and also fresh water is salt water, that is based on the salinity amount of salt. Now, what are the essential properties of water? Number 1, so it is a main agent for soil formation. One of the main agents in soil formation. The formation of soil is called pedogenesis. Then it is a medium for several ecosystems. That is what we have the pond ecosystem, or we have any other ecosystem. So it is present as moisture in the atmosphere as well as in the outer lithosphere. Outer lithosphere just outside the surface of the soil. And it shows uneven distribution. In some places we have more, in some places less. That is called uneven distribution. Suppose we are comparing, that is water. So it is normally heavier than air. If we are comparing water and air, it is heavier than air. So that it imparts greater buoyancy. Buoyancy means the floating effect. To the aquatic medium. As there is a buoyancy, the organisms, or it enables the organisms to float at various levels. Upper level, medium level, or at the lower level. This is because of the buoyancy. This is because of the heavier nature of water than air, giving floating effect. Then, physically, water is unique in nature because it is less dense in solid medium, that is ice, than in liquid medium. It is less dense. That's why ice is floating. This is because of the less density. So it is physically unique, the physical property, less dense in solid medium than in liquid medium. That is, ice is floating because of what is called this property of what is called less dense in solid state. Now we have to go 4 more properties of water. Now other properties of water. So water has high heat capacity and latent heat. so due to which it withhold a large amount of heat. Now the seas and lakes maintain constant temperature because of the heat retaining capacity of water. Now because of that what is called heat bearing capacity, heat holding capacity, the entire biosphere is thermostable, not exhibiting greater changes in temperature. Now the next one, the character. When water freezes to 0 degrees Celsius, it contracts. The maximum density of liquid water is at 4 degrees Celsius. Below 4 degrees Celsius, what will happen? It expanded. That is why what we have, the icebergs. The ice is floating on the surface of water. This is because of the expansion of what is called the water below 4 degrees Celsius. So this enables ice to float on the top of the water bodies. Now, normally because of what is this property, the surface of water bodies freeze. But what is happening below the surface water, the water is always in liquid form, maintaining or sustaining the normal life. Now it is acting as a universal solvent, acting as a main medium in transporting the chemical constituents from the abiotic component, the non-living matter, the non-living actually factors, to the living component of the ecosystem. This is because of its universal solvent nature. Now, the next one, it is having high surface tension. It is having high surface tension. So, as a result, it allows the pollen grains, dust, or even the water strider. Water strider. Water strider is nothing but the small insects, for example, water spider, floating on the surface. So that these organisms are able to just float on the surface of water. Even though these are what we have the objects, what I mentioned, just the water, the pollen grains are large dust particles. The insects, water spider, normally called as the water striders. Normally the animals moving on water surface are called water striders. They can float easily on the surface of water. This is because of what is called high surface tension of water. Even though these structures, the objects are heavier and denser than water, they can float easily on the surface of water. This is because of high surface tension of water. So these are all the properties of water, essential properties. How far they are essential to the life also. Because of these properties, they have normally some important actually influences on the life of an organisms. Okay, that's about water. What is water? Types of water, the essential properties of water. Now the next abiotic factor is soil. What is soil? It is nothing but a mixture of organic matter, the minerals, the gases, liquids, and also the organisms that together, all these things together support the life. And normally the soil zone is called what is known as a pedosphere. The process of formation of soil particles from the rock, which is a parent material, by weathering process is called what is known as pedogenesis. What are the main functions of the soil? Number one, it is acting as a medium. It is acting as a medium for plant growth. Acting as a medium for plant growth. Then concerned with water storage and purification, because it is acting as a filter. Even in the case of sewage treatment plant, we have what is called the different layers of soil of different sized particles. So water storage and purification. And it is a modifier of Earth's atmosphere. Earth's atmosphere being changed, even what is called after rainy season, you know that one, we have the change in color of the water. This is because of the soil. And it is a habitat for many organisms, the living microorganisms, the macroorganisms, which in turn modify the soil nature. Okay, these are the four main functions. What is soil profile? Now, soil is formed of many horizontal layers which together constitute a soil profile. Now we have to go for the characteristics or the properties of soil. In nutshell, I will conclude quickly. Number 1, soil texture. Number 2, what is called porosity of soil. Then permeability of soil, soil temperature and soil water. What are the properties of the soil? Number 1, texture of the soil. The texture refers to the smoothness or roughness or coarseness of the soil. Now the texture of the soil is normally determined by the size of the soil particles. Larger the size, the texture is rough or coarse. Smaller the size, the soil texture is smooth or soft. Now based on the size of the soil particles, we have 3 different types of soil. Number 1, sand. Number 2, silt. And number 3, clay. Sand, silt and clay. Now the next property, the porosity of the soil. Now the spaces present between the soil particles in a given volume of soil, normally they are called as the pore spaces. What is the porosity? The percentage of soil volume occupied by the pore spaces. The percentage of soil volume occupied by the pore spaces or interstitial spaces, that is in between the soil particles, is called the porosity of the soil. More is the porosity, the water holding capacity is less. Now the permeability of the soil, the next property. The characteristic of soil that determines the movement of water through the pore spaces is called what is known as its permeability. Okay, the main characteristic of the soil that decides the movement of water through the pore spaces is called as the permeability of the soil. Now if the soil permeability, normally you know that one, it is directly dependent on pore size. If the pore size is larger, the permeability is more. If the pore size is smaller, then the permeability is less. So directly dependent on pore size. That is the soil permeability. And what about the water holding capacity of the soil? The water holding capacity of the soil is indirectly dependent on what is called soil porosity. If the soil porosity is more, we have more spaces, large spaces, then the water holding capacity is less. They should have what is called small sized pores. Then only they can hold what is called large amount of water in the form of capillary water. That's about the 3 properties. We have 2 more. One is soil temperature, another one what we have soil water. A few words. Other properties of the soil, there is a 4th one, soil temperature. What is the source of heat energy for the soil? It gets heat energy either from solar radiation or decomposing organic matter or from the interior of earth. That's a source. What is its effects of temperature on organisms? So soil temperature is responsible for seed germination. So suitable soil temperature is needed for the germination of seeds, the growth of the roots, then biological activity of soil inhabiting micro and macroorganisms. That's about the effect of what we call soil temperature. The last one, soil water. So the soil water is not only a solvent, but also is not only a solvent and a transporting medium. These are the major properties normally. In addition to that one, they also maintains a soil texture. The arrangement and compactness of soil particles, that is holding capacity of the soil, making the soils held together, soil particles, and making the soil habitable, a living place for plants and animals. That's about what we have the important effects of soil water. Role of soil water becomes a use of soil water. Okay. With that I conclude about the soil. We have to go some more abiotic factors in the next class. Thank you.